Good morning. My panelists are not here in Glen Cove, so I'll try to still to do a good job. And maybe to piggyback on last year we had a few people presenting technologies, Flettner rotor, suction sail, ocean wings, and Dynarig. We're trying to do a little bit different this year. So all those presentations are available on website if you want to get back to them. Here we'll try to address a little more one step further. So where is that market for wind propulsion technology is going? Also, what are sort of the challenges? What policy frameworks are being implemented to deliver a fair ground for those technologies to emerge. And I'll get started by introducing the panel discussion. So we have, where do we start with? Let's start with Guillaume. He's the head of ship department at Marine Institute. And Guillaume, each of you, I will give you half a minute later on to introduce yourself. Adrien Simonet is the head of Neoline Development, a startup bringing a RoRo vessel wind-powered. We do have Gavin Allwright. He's the Secretary General of the International Windship Association. Sorry. And last but not least, Yanoto Decat, who's the Regulatory Affairs Manager at the Maersk McKinney Moller Center for Zero Emission. We don't see you, Jan, but I hope you're on the panel. Anyway, let's get started. Gavin, can you give us like a half a minute introduction of yourself, and then we'll turn.
Yeah, sure. So my name is Gavin Allwright, Secretary General of the International Windship Association, which is an association bringing together the whole ecosystem around wind propulsion globally. We have over 150 active members, everything from ship owners to class to shipyards, even charters. And yeah, my background, I have a master's degree in sustainable development and NGO management, and a background in working for sustainable shipping NGOs. And I'm currently the representative at the IMO for IWSA and on the European Sustainable Shipping Forum, among other things.
Guillaume?
Yes, good morning. Very happy to be here again this year. Guillaume Gaillard, I'm head of the ships department at Maritime Research Institute in the Netherlands. We are busy at the Institute since about 15 years to promote alternative solutions with respect to zero-emission shipping, but mainly starting with wind propulsion. When we are looking at the amount of work we are doing now on sustainable ships, well, it's not the majority of ships. Many ships are still optimized and planned to be built with other type of energy, in particular fossil. But we see a growing number of ships going through optimization, design concepts, firstly with alternative power, wind assistance, but now also a few projects with fully wind powered. And I will present a bit more later. So I'm also involved, like Gavin, on the at IMO level through the European Commission and through the European Sustainable Shipping Forum. So not directly involved there at the IMO, but acting as expert there to try to.
Thank you, Guillaume. Adrien?
Yes, hello everybody. I'm Adrien Simonet. I'm one of the founders of Neoline and actual development manager of the company. Neoline is a French project created in 2015 by 9 founders mainly from the shipping industry. I'm myself captain on a merchant marine vessel. And we have developed a RORO concept, which will use sails as main propulsion. So I will contradict a little bit Paolo by saying that wind is maybe not enough, but fuel is also not enough, and we will need to combine all energies to be able to decarbonize shipping. And if in the particularity of Neoline is to promote main propulsion with sails, and this needs also operational measures. So it's also the intention to not make business as usual.
Thank you. And last but not least, Jan, thank you for joining.
Good morning. Thank you for letting me getting connected here. So yeah, I'm based in Copenhagen with the Maersk Møller Center for Zero Carbon Shipping, where I've been working for the last year or so, dealing with a lot of the issues we heard in the previous presentation, by the way. Before joining the center, I was with the American Bureau of Shipping for almost a decade, dealing with energy efficiency, vessel performance, and regulatory issues. And before joining ABS, I was with A.P. Møller Maersk as head of innovation, and way before then was with Marin a good many years as head of R&D for the last 7 years or so. And I remember, Guilhem, we started the WISP project, the Joint Industry Project, while discussing the need to actually look at how to do, let's say, a level playing field performance evaluation for wind-assisted propulsion systems. So I think the project has been developing and still ongoing right now, as it is. I'm also involved with coordinating this ESSF, the European Ships Sustainability Forum, and where we have a wind stream where Gavin is also heavily involved in. So maybe we'll talk more about this later. Thanks.
Sure, you will. We will. Thank you. I'd like to start maybe with a bouncing back on the presentation we had on the financing of the decarbonization. And I like maybe Gavin to pick up the ball. A number did strike me, and that's not the first time I could read about this number. More than $1 trillion. So I don't know how many zeros that means, but it's quite a few zeros. Gavin, I'd like you to pick up the ball, and I guess it's a huge market for your members. So $1 trillion. So please tell us more about that, what that means. And what...
Yeah, sure. So the $1 trillion I think you're referring to is the cost of reaching IMO 2050, and it's also linked with a statement that I've put together around the actual savings if we were to roll out wind propulsion comprehensively across the fleet this decade. The amount of fuel savings based on actually slightly lower fuel costs than we have today that would accrue from an extensive wind propulsion rollout across the fleet. So interestingly, as I mentioned, this would actually equal the amount that's required for IMO 2050. And indeed, if we increase the fuel price to today's fuel price, more likely to be around the 1.4, 1.5 trillion level, which actually is the cost of the full decarbonization as assessed by UMass and the Energy Commission's the Energy Transition Commission. So, really, the interesting thing that it also points out is the fact that wind propulsion is the only propulsive energy provider for ships that will actually have a return on investment. All of the other alternatives that we're looking at present, all of the alternative fuels, which of course we need, will be more expensive than the existing fuels that we're using, especially HFO and VLSFO. So those will be a full cost. And as you say, rightly so, it is a huge market. I mean, we're looking at 60,000, between 60,000 and 100,000 vessels that are large and that need to be retrofitted. Of course, I think probably we're looking at 1,500 to 2,500 new builds every year coming through. So as wind-ready vessels, as wind assist or primary wind vessels, that's a very large market indeed. And we're only just scratching the surface. By the end of this year, we'll have 25 large vessels in operation with wind assist, around 1.4 million deadweight tons of ships. By the end of next year, that will be at least up to, I think, 49, and doubling that tonnage at least. So we're not quite grasping the nettle on the size of the market yet, but you can see that numbers are already doubling, and we could effectively say they're tripling from this year, next year. So potentially exponential growth coming through.
Thank you, Gavin. Jan, I'd like you to help us understand what's going on in the EU. There's a lot happening in terms of a policy framework, market-based measure, experimentation that we don't see much, or let's say not as much happening here in the US. So would you please sort of describe what is the EU doing? What is the EU trying to accelerate or give room to grow? Please, thank you.
Yeah, definitely happening here. And I guess we'll maybe see first here in the EU, then hopefully it will trickle down further to the IMO and international level. We start looking at it more globally. But here in Europe, and that's not only for maritime, the European Commission has come out with this Fit for 55 package. And essentially it's, you could say, a basket of measures aimed at decarbonizing all of the sectors in the EU. And for the first time, you could say shipping is now also being included. And there's two specific elements that are of direct relevance to us in the shipping industry. One is the emission trading scheme that is going to be effective. Essentially, it's a carbon pricing mechanism, which will be starting around 2025 or so, with the idea that gradually more and more cost will be associated with how much CO2 you emit per ship or per operations, depending how you consider the operations. But so there you could say it is going to be having some, of course, an impact on everyone where you have CO2 being emitted. And here again, wind propulsion, of course, will help in trying to say, hey, if you save 5%, say, for example, in your emissions, that will also have a bearing on the cost you have to pay in terms of the ETS scheme. But there's another one called the Fuel EU Maritime as part of that whole basket of measures. And this one, there's a specific reference to wind propulsion. Basically, the idea with the Fuel EU concept is ETS is a carbon pricing, and the Fuel EU has the objective to accelerate the shift to low sulfur, not low sulfur, but say zero carbon fuels, essentially in the longer run. And so with that, there's a focus on what's the greenhouse gas intensity for each fuel. And as we go in terms of, let's say, times forward, that intensity will become more and more restrictive in terms of the greenhouse gas emissions you can emit per, let's say, energy output of the given fuel. And so now, if you have a wind propulsion system, there is a so-called reward factor. Now, in terms of this greenhouse gas intensity factor for each fuel, so you say, okay, if you have a wind propulsion system and it provides on average, say, a 5% savings compared with, or let's say less reduction in your propulsion power requirements, or maybe it's even up to 10% of your total propulsion power required that comes from wind, then you get a certain percentage reward. And yeah, the numbers are not so convincingly high, I would say. I don't know, Kevin has been following these discussions from close up. I think there were some proposals actually to change the reward factor and also try to even give more credit to wind than was originally proposed. That proposal, I don't think, Gavin, it got the okay, huh? I think.
Yeah, in Parliament, we got 243 votes for, 390 votes against. So we weren't able to get it through Parliament, but we're still trying.
There's still hope. So anyway, so this one, that's one that has the specific elements in wind propulsion. And also it actually relates to sort of IMO because it uses the IMO methodology that you now have in place for EEDI purposes. If you have a wind propulsion system, you look at this global wind matrix and then apply the force evaluation and the thrust basically you get out of the wind propulsion system. And that sort of gives you an average global over, let's say, integrated over all of the wind directions and speeds and so on, that say, okay, this is what you can deduct. So anyway, so wind propulsion is definitely on the agenda at the EU level. As said, it's still an ongoing discussion. It hasn't been completely finalized yet. There's going to be this so-called trilogue discussion to finalize the final, say, version for the fuel EU. It will also get into, let's say, into force essentially parallel then with the ETS, the emission trading scheme. So I think that's really one of the famous, let's say, the relevant ones. And there's also a renewable energy directive. I think Gavin has been trying to argue that hey, wind is a fuel. It's not just, let's say, a contributor to your propulsion as a power system. That hasn't been, at least not, I don't think, accepted yet. But so there's at least, this is a good thing in the EU. There's a room for dialogue, and we have a very close contact with the EU, with the European Commission. So there's definitely, as Gavin was saying, there's still hope that we can do more. Thanks.
Thank you. Thank you for that. Gavin, recently, the International Windship Association and the actually French chapter released a very good paper, a white paper on wind propulsion, covering some sort of technical aspect, what's available out there, but also the framework, the industry that's building up. Gavin, I'd like to maybe tell us why that was needed. Why at one point the industry had to come together and put that white paper, and what does it bring? So please enlighten us on that.
Yeah, actually, I mean, this is I can't take that much credit for it because the French chapter, which is Association Windship, did a huge amount of work around this. Really, we provided the global side of that, the aspects on the wider international aspects, but the French chapter put together if you like, an example of a national development, a national cluster that's been developing. So, we've been developing this for the last 3 or 4 years. Why was it necessary? Well, actually, this fits into our strategy of we've been as transparent as possible throughout, having the International Windship Association there. The white paper feeds into a sequence of reports and documents that are coming out. So we have actually an IMO submission as well, which is about a 35-page IMO submission for as an info document, which was developed partly in tandem with the white paper, but we're also developing another sort of global focused white paper. Which through the ESSF will also be coming out hopefully by the end of the year. So why was this necessary? I think a couple of critical things. One is that the developers of decarbonisation pathways, including the one that the organisation Jan works for, the Maersk Muller Center, A lot of these decarbonisation centres have been pretty much brushing over wind, saying, oh, yeah, a little bit of wind, you can put a bit of that on a ship. But everything is fuel-centric. Everything focuses on, we can reduce 10% from fuel by putting some rotors on a ship or a kite on a ship. Whereas what we really need to be looking at is an energy-centric approach. And I think Adrian referred to this, looking at far more from a holistic point of view. How does speed interact with wind? How does all of the other weather routing, having sensors, LiDAR on the vessels? How does a rethinking of the network that we're using, and for example, green corridors is a very good example of this, of saying, well, actually, we already have green corridors. They're called the trade winds, but we just don't use them anymore. So marrying what is being seen as green corridors today, which is a very fuel-centric approach, but marrying those up with wind corridors and saying, actually, if we want to decarbonize quickly, we need to be looking at using all energy sources very much in a holistic mix. The other part of the white paper that was really important, and this is increasingly important, is it's focusing on the not just the economics in the shipping industry, but the jobs, the investment, the revitalizations, for example, of smaller shipyards in this case in Europe, and the virtuous circle that the development of wind propulsion can create in local economies, in regional economies, in national economies, and my job is to take that globally. And we've got to remember that shipping is only a very small percentage of the energy transition that we require, and wind propulsion is only a small technology segment within that. What we need to be talking to are the financial institutions, the politicians who make the decisions, who maybe aren't maritime savvy. They don't know very much about shipping, but saying that this actually feeds into the energy transition and removes a significant part of a vital industry away from the volatility and obviously the emissions, etc., and the costs of the fossil fuel provisions that we've grown accustomed to. So hopefully that's a quick answer for you.
No, thank you, and it's a good transition. And as GM at Marine Institute, you obviously work with many shipping companies, or let's say maritime transport. Why are they coming to you in terms of wind? And maybe you can help us answer the question: is wind a fuel, or is it an energy-saving device?
Well, thank you very much for this question. It has been, I think, the first question we asked when we started the let's say the work group on introducing wind at two work group at the European Sustainable Shipping Forum, because there was one group focusing on sustainable alternative power for ships, and originally that was called sustainable alternative fuel for ships. So we said, no, we want to call it power. And the second group was a group on ship efficiency. And since the start of the work group, we have been debating about, is the wind going to be like an energy efficiency asset, or is it can also be used as primary propulsion device? So the debate is still there, but I think I think the debate will remain, because some people are going to use wind as a supplement, typically called as assistance. So you have, let's say, business as usual, relying your transport on engine power and energy carriers that can be seen as fuels, and then adding the wind assets to improve the performance. So that's typically part of people who come here at Marine to consult. They want to improve an existing design. So it's business as usual, and trying to add energy saving devices, trying to add limited amount of power from cells. So in all those projects, wind will be seen as an additional, let's say, a chance to reduce energy consumption. Then on the other side of the spectrum, we have companies coming to us, and they're not doing business as usual. They just want to create the unusual. So the starting point of the design, the starting point of the trade, of the logistics, is based on use of wind as main propulsion device. And then it's not only about.
Let me interrupt you, and I'm sorry, we'll come back to you, but since you're mentioning those companies that believe wind is actually a fuel, Adrien is representing Neoline, and I'd like to give him the opportunity to let us know about that.
Yes, first I would like to speak after Gavin about the white paper, because we participated in its redaction and in its writing, and for us it's a very good tool to convince decision makers. We have written a great picture of the situation. We have written also the prospective actions that can be made, the benefits that can be held environmentally and economically, and it's very interesting to see that. You have to know that today it's more profitable to build a coal carrier in China, which will burn heavy fuel oil, than to build a ship with sail propulsion system or ecological systems on board. It's still, we don't have sufficient heads to fill the gap between the business as usual and the business as not usual. So this white paper is very important for us, and we are using it a lot. Regarding the main propulsion, when we started to speak about our project, it was a long time ago. We created Neoline in 2015, but it's been 15 years that we are working on it. People were looking at us like strange guys. It was very hard to convince, but because also we believe that it was necessary to have operational measures besides the technological progress. So we use the sails, but also we reduce the speed to allow us to use sail as main propulsion. And we convinced several shippers directly. We went to see to find our market, and we convinced several shippers. And today we have one ship which is planned. It's not yet in construction, but I hope it will be very soon. Some good announcements, but not for now exactly. But the ship doesn't exist, but it's already full on the westbound trade, so with European shippers. So we find our market, and then we succeed to get some finances. But it's still hard, and we have some public aids in that. But it is, even with this public aids, it is still more profitable to build a coal carrier burning heavy fuel oil than building a clean ship.
Yeah, thank you, Adrien. Maybe I'd like you to again, we are talking about technology here for wind propulsion. You did recently announce sort of a rigging system that will be used on the Neoliner. One, can you tell us a little more about that? And before that, I think there's a very new momentum in this wind technology provider. It used to be startups, small companies saying, okay, I'm going to build a Flettner rotor, a wing, but that's tough for large shipping companies to get started and work with the shipping companies. What we are seeing now is very large companies in Europe that are developing technologies. Michelin is one of them. And Adrien, you're starting with Chantier de l'Atlantique, which is building the very, very large cruise ships. And they also now bring a rigging device. So can you help us understand sort of the rationale behind going to that technology and tell us a little bit more about this technology?
So if I may share my screen, I prepared a slide about this. I think it will. Can you see my screen?
You should be able to. Yeah, you should be able to.
Yeah.
Okay, we see.
You see it. So on the left side of the screen, you have the former design of the ship, and in December 2021, yes, no, 2020, there's a mistake on the slide. We made the choice to, no, December 2021, excuse me. It's not correct on the slide. We made the choice to change the rigging system with a solid sail developed by Chantier de l'Atlantique. So as you said, Laurent, it's a major shipyard in France. And it's, in fact, it's at my knowledge, it must be the only rigging system developed integrally by a shipyard. Maybe Gavin or Guillaume tell me wrong, but I think all others are specific technology providers. So it's very interesting for us because we have a ship owner project. Neodyne is not a technology developer provider, it's a ship owner project, and we assemble mature technological bricks on board. The first design was a duplex rigging. It has nice aerodynamics capacities, but many big stresses inside the rigging. We made the choice of the duplex because the compression efforts of the mast were taken by the frame of the ship. The big advantage at this point of solid sail is that it's self-sustained rigging, so there's less compression. There is only the weight of the rigging, which is held by the deck. So we don't need to have big structures under it, because the ship is a ro-ro ship. As you can see on the right, there is a ramp at the aft. So we need a very free space inside the garage to make our cargo operations. So we have now this partnership with Chantier de l'Atlantique, and we should be the first ship which will install this technology on board.
Thank you, Adrien. Thank you very much. We have another 10 minutes before question answers. Gavin, I'd like to come back to you on the International Windship Association and members growing technology providers, class societies. Tell us more about like how wind propulsion is finding its spot in the industry.
Well, that's a very broad question, but I'm in Seoul at the moment. I'm at the Korean Naval Architects Conference. Actually, I'm not in Seoul. I'm in Changwon, down near Busan. And I think Asia is a really good example of how this niche is actually forming. Adrian mentioned about Chantier de l'Atlantique, and it's absolutely right about shipbuilders in Europe. But actually, the developments over here in Asia are really starting to pick up now. We have a number of our members have moved their production facilities over to China. We have one Dalian ship builders have worked with CMES to install 2 VLCCs now with a homegrown wing sail that they've developed. But we've also got, for example, Hyundai Heavy Industries, COSCO Shipping, which is another quite large shipyard. We have Sumitomo Heavy Industries, which is one of our members, all Samsung Heavy Industry as well, all developing their own systems that are starting to get AIPs, and I think Samsung has just got their full design capability for a Flettner rotor of their own design. So I think what's happening now is that we're moving from the single demonstrator vessels, and we're starting to see a bit of the first signs of some maturity coming in, where we've got, as I mentioned, the production lines are moving to where these need to be done en masse. The shipyards over here are starting to look at having systems as standards in the shipyards. And that makes a big difference when you have a piece of equipment as a standard. But also we've got, and I think Adrian's, the Neoline project is a really good example of this, is where the cargo owners and the charterers are starting to say, hey, you know what, this is what we want. This is a technology that we can move on immediately and have an impact, if it's 5%, if it's 10%, or if it's 90%. And we're starting to also see a number of companies coming together in consortia. I know CGM, CMA have just invested in Neoline. We have Yara International working with Bar Technologies. So bringing an industrial partner together with the technology provider, because actually one of the big problems and one of the pinch points will be, as OEMs, as small operators start moving into the full-scale production and replicating and scaling these technologies, that's where the real pinch point comes, because that takes a lot. It takes a lot of investment, and it takes a lot of know-how to really scale this across the fleet. So we're starting to see those elements of maturity, just as the demonstrators increasingly are coming through. But I'd say that there are two critical issues. One is the demonstrators. I haven't been able to do my job until there's enough ships out there demonstrating that to the industry that wind is a credible energy source. Of course, we've got small vessels operating on this, but when large vessels start to operate with this and large actors come in, that's really important. And the second one is, and I think this is very much the case with Neoline, is when cargo owners, charterers actually give solid commitments, they will move their cargo over an extended period of time with a certain ship. Michelin has just done this with a tender for 10 600 TEU container vessels, guaranteeing cargo to those. You guarantee the cargo and you then build the ships around. And I think that is where we're now kind of, the niche has been formed. We're now moving into the early stages of that scaling and maturity.
Thank you, Gavin. Guillaume, I'd like to come back to you. I cut you off a little bit earlier, but tell us what new designs are coming? What's cooking out there?
Well, unfortunately, I will not be able to talk about the actual projects. We are bound to very much, let's say, secrecy with all the clients coming here and all the companies. But generally speaking, as I earlier mentioned, we have most of the projects that we're working on are now also public, because it's important to draw attention to those projects. But what Gavin is really true. People need to get used to these new technologies. They need to be convinced that it's working. So let's say the first ship sailings, and I think that the Canopy, for example, will be a good example. I think that will be the first one. That will show people that, yes, it's possible. And then, of course, they will ask us afterwards, well, why didn't we start before? Well, actually, we have been now spending 15 years trying to convince everybody it's possible. But what I see the very big change at this moment is that we went from like pioneering spirit of few people taking risk in looking at alternative solutions now to very serious, let's say serious in the sense large companies who take this solution very seriously and ask us not only now to do the feasibility part and is it possible. They went through this path already, and they know it will bring some advantage. Ask us to actually predict the sorry, Gavin, I think there's a bit of sound from your side, but
sorry.
But they ask us to, let's say, predict what will be the benefits, to quantify the reduction in emission and the reduction in energy use. So they're going to very pragmatic questions, and they also realize that we are still far away from having explored all the options, because you start with small devices, starting with assistance, and now there's a kind of moment where people start to, let's say, change the constraint related to transport, so maybe a longer trip duration, different types of logistics, and they see that slowly they are opening the way to even more alternative designs, even up to full wind propulsion. So it's a very interesting time. Questions are increasing every month, and we are quite happy about it. And that means, obviously, that within, I think, 2 to 3, 4 years, there will be quite a lot of ships relying on wind to transport goods around the world.
Thank you, Guillaume. Adrien, I know you need to catch a train, so if you want to take 30 seconds, 1 minute, please be our guest.
I have nothing special to add right now. Just to thank you, Laurent and Bradley, for inviting me and let me the opportunity to speak about Noline on the other side of the Atlantic. That's it.
Thank you. Maybe one last question for our panelists. What can the US do? What do you think? How can they contribute in some way?
I have one answer. To give some freight, some eastbound freight to Noline. Like this, we are full on the 2 sides of the Atlantic.
Yeah, thank you.
But it's something for us. It was easier to have discussion with shippers in Europe. There is the trade is unbalanced between Europe and US. There is more westbound freight than eastbound freight, so we focused on the westbound, but we still have some place for the eastbound freight. So that's our next moves in the US will be will be more commercial than technological.
Yeah, thank you.
And
Jan, David, or Guillaume, yeah.
Yeah, maybe on that point, that's a good point about the westbound and eastbound, because if you look at across Atlantic eastbound, then the winds are much more favorable. So you can actually you can use much more wind going from US to Europe. So that's even better for sailing conditions. But I would say there's a lot of technology at this moment being developed in Europe. We should look back what happened the last 20 years. Why is it so? Because I mean, US. We still have the idea that from, let's say, US initiative, there has been a lot of incredible new things coming with electric cars, with space exploration. So what we should tell maybe students and future engineers that there's a lot of things to do also on wind propulsion and going zero emission transport. So don't look only at the roads, don't look only at the space, look at the sea. And there's a lot of incredible things to do there. So, and we know that if the engineers and companies will start to move there in US, then it will go extremely fast. So join the club. There's a lot of work to do, a lot of innovation to still find, and future is very promising there.
I think another good thing, at least interesting thing about the US is the current administration has a lot of interest in decarbonization. Also, when it comes to shipping, they have, for example, quite interested, I think, in green corridors. So it'd be really good if you could say, okay, develop a green corridor. We have wind propulsion as part of the, let's say, technologies that are being applied. I would say the other main driver really will have to be coming from the policy making side, and that is carbon pricing. Without the carbon pricing in place, it will not be a huge, let's say, impetus, or let's say encouragement to invest in the wind propulsion technology. So of course, we see them now, and we see the certain owners and so on who are willing to do this. But if there is a strong, pricing mechanism in place, whether from the shippers, whoever we heard from before, I think that would be a very good, let's say, accelerating factor for wind propulsion, because also when it comes to the new fuels, and we're talking about ammonia, methanol, hydrogen, and so on, it still makes good sense to be as energy efficient as possible. And whether you consider the fuel or energy efficiency, the less fuel you consume, the better it is. So no matter what the fuel. So I would say here we also hopefully we get a push from the US side.
Thank you, Jan. And Gavin, what? You're on mute.
There we go. Am I back? Yeah, we're good. I completely agree with everything that's just been said. On top of that, I mean, for example, be aware of the opportunities. With the Jones Act, for example, there are great opportunities to outfit the American fleet, and when that comes into American yards, have those yards ready to take wind propulsion systems. Carbon pricing, definitely. The Clean Shipping Act is quite a progressive looking piece of legislation as well, in the similar ilk to the Fuel EU Maritime. So I would say, I don't know all of the ins and outs, but I would say supporting that to a degree would be very important. A couple of others. One is around what Adrian was saying about cargo, and for example, I think it's COSEV, the coalition that Amazon has joined, and a number of others have joined. Michelin is part of that as well. Really pushing for support of low emission shipping, and then moving to zero emission shipping quickly in the 2030s and 2040s. I've talked with them myself, and they were really surprised about the wind propulsion developments. So it's talking to these large companies and saying, look, there is an option and it's available right now. The last thing I would say, actually, if there are any politicians or anybody from the Department of Transport there, is fund an analysis of the US fleet, the US capability to actually become one of the pioneers in wind propulsion. This is still up for grabs, if you like. A lot of countries are starting to jockey for position. They're subsidizing or promoting the technology providers, the shipyards that are developing systems, but we're in the really early stages of that. So the more competitors we have in there, the quicker the prices are going to, or the costs are going to start coming down, making them more attractive. So it just creates that whole positive cycle. So if there are any Department of Transport people listening, then you just have to pick up the phone and give me a call and we can get that moving.
Thank you, Gavin. It's a good positive note to close the panel. We're opening up to questions. Anyone with yes?
Hello, how you doing? If you could just turn the camera. Yeah, that's your microphone. I heard, I know the discussion about wind as fuel, and it's funny because you listen to a panel discussion, you kind of check your phone real quick, and it was obvious actually when I looked it up. But fuel is related to French effet, which is fire, and so fuel is something you can burn. So wind is not a fuel. It actually is it's actually a form of energy. It sits a little higher because in many ways it's limitless. And of course, fuel has the advantage it's portable. You can carry it around. Those are the two things that we kind of live with. What I realized.
Could I just come in on that point? Actually, the EU definition of fuel is any energy source that replaces in part or fully another energy source. So it does come under the definition of a fuel, but you're absolutely right. the root of the word is fire or combustion. Yeah.
Right, but the interesting part of all of this that I've come to realize in the last couple of years is that as naval architects and marine engineers, we've been incredibly linear. We think of ship, propulsion plant, amount of fuel needed to make a ship move. Instead, the world is changing and the world's becoming more hybrid design. And we might not be doing ourselves a favor by calling wind to fuel because it's a resource that can be picked up during the voyage, so to speak. So as a hybrid designer, you have to start looking into these trade-offs. And the one thing, of course, I'm starting to discover is that, well, it used to be that because oil, fossil fuels, that basically fits every route, every shipping route you have. The really hilarious part is that we're really working ourselves into very strong job security because every route needs to be analyzed and designed to have the proper vessel for that particular trip. And that means we engage all the types of fuels now quotation marks, that you can find, which being wind, having the advantage, you don't have to carry around a ship, and solar, even although ships is not super efficient, but solar being another factor that does the same thing. So I think I found the discussion interesting, but I also found it to be probably most accurately say technically incorrect because we know better. We shouldn't really call wind fuel because it's a different tool. It's different.
Yeah, can I come in on that just as a second? So what we actually call it and what our discussion is mainly around is that wind propulsion is an energy source, and the problem that we've got is in the policy discussion. Fuels are attracting subsidies and a lot of how can I say preferential treatment. Wind propulsion, therefore, is not seen as a commoditized fuel. It's an uncommoditized energy source. Therefore, it doesn't qualify for any kind of special treatment. Therefore, in their framework, what I would like to see is, okay, let's call them energy sources. And actually, the fuels are not energy sources. They are stores of energy, whereas wind propulsion is, in fact, a direct energy source. So it's quite interesting if you capture the wind and then put it into electricity and then make an electro fuel out of it, then you've got a fuel. If you produce wind propulsion from a turbine on a ship, that's you're running the ship with a large amount of wind propulsion on board. You drop some or some hydro turbines into the water, generate electricity, and then you've got a fuel on board. The wind propulsion is seen as an energy efficiency measure, but the electricity generated e-fuel that you generated because you had lots of wind is designated as a fuel. And it's quite an interesting paradox that you end up arguing that wind has to be designated as a fuel rather than the fuels have to be designated as energy. So I completely agree with you that it is paradoxical, but we're fully aware of that.
Well, the interesting part is actually fuel is an inferior source of ship propulsion power.
Absolutely.
And that's an argument I was trying to make is that you have available energy and you have energy you have to pick up in the marketplace. And so, there were two levels of this. One was designation, but the interesting part that I think that is probably my main point is that as engineers, we shouldn't get sucked into these debates. We should really speak to the stone cold truth. And the stone cold truth is that now that we take cargo load into account, we have to think of customized door-to-door solutions everywhere we go, which is kind of cool. From my point of view as an engineer, it's kind of cool now. I get to really just keep thinking instead of simply grab an engine from the shelf.
Yeah. Thank you. Any other questions, maybe on the chat?
No, there's nothing on the chat. I think we're good.
Okay. I'd like to thank you very much, our 4 panelists. Adrien is off, but thank you, Jan, Gavin, and Guillaume.
You're welcome.
Thanks a lot, and thank you everyone for listening and participating.